Hi, everyone. In this session, I'm going to be talking about object-oriented programming. So let's get started. With object-oriented programming, there are four paradigms of object-oriented programming, which are abstraction. The first one is abstraction or data type, data hiding. And basically, when you see the goose picture here, or the image of the goose, you're seeing an abstract object. We don't know the details are hidden until we just go through each attributes. Similarly with the object turtle or duck or bird or fish, every object that we are seeing is just kind of like a interface we see as abstract data type or data hiding in this case. And then when you see another object, that is the definition of classes, one part of it is encapsulation for the paradigms that for concept. Encapsulation meaning that when you create an instance of an object, you're putting that object into a capsule kind of form. Encapsulation meaning that, for example, when you see the capsule itself or the medication, the data or the medication is hidden between the capsule. That's why it's called encapsulation. Similarly, like if you see the remote controller, the interfaces, the front end that we all see, those buttons and functions that you could push in to turn on the TV or the computer, like a keyboard or buttons, and each one of them there's an interface. So that is data hiding or encapsulation that you can see. When you see a car object, for example, the car itself is almost like an object of an instance of different type of cars, right? So the car itself, when you see it, but when you're driving it, the driver, you are just pushing different buttons to start the car, and then when you start the car, you accelerate, you move the car. There are different methods you can apply to it, but unfortunately, when you're seeing for privacy reasons, sometimes when you define the class, not unfortunately, fortunately, you can make some of these data hide it. The detail doesn't have to be defined upfront. So you can see there an example of a fish, a beautiful fish going in there, and then the turtles. They're all getting along. That's a nice thing about it. I'm going to talk about abstraction, data hiding, encapsulation, inheritance, and polymorphisms. Inheritance is almost a type of subclass, basically. So each class that you, for example, you create a class called animals, and then there are 5 or many subclasses. This video, you could see 5 different subclasses. The class goose, which also inherits all the common attributes and methods from the animal class, superclass, and then the subclass would be the goose subclass. And then similarly, the subclass turtle would be another subclass, and the duck would be another subclass, the fish would be another subclass, the bird would be another subclass. So each one of them, they have some common attribute from the animal kind of the attributes. Notice right now, the duck had some sort of polymorphism methods. So they can go outside of the water and inside a different type of time, they react differently. Their behavior changes based on what they want to do. Some of those methods or options that they have is a lot different than another subclasses. For example, a turtle, you can see that it can swim as well as can go outside of the water, but fish cannot go outside of the water. So that's certain features or functionality. We call it an object-oriented. A function is method, and then a variable is called attribute or properties. So each of this, like you can see the duck right now, you can see the paws or kind of like a web kind of feet that you have the option as the bird to just walk on the grass area and then eat the grass, as well as go to the water and swim like a goose or like a duck. They can all swim because look at their feet. They're web kind of feet that they can swim faster. Even when people swim, they can just wear something like that and then just swim much faster. So a lot of these objects that we are looking at it as basically in a template form, they're called classes. Classes are basically the blueprint of every object that you can see in real life. Everything in life can be defined as object. So object-oriented programming language, it is a methodology that allows you to do these four paradigm, which is abstraction or data hiding, encapsulation, inheritance, and polymorphism. Polymorphism meaning poly means money and morph means forms and taking many forms. For example, a duck, you can see when it gets to the water, it swims. When it gets outside of the water, it just could walk or and fly as well. So that's multiple forms, different methods, and different functionality. And function programming, a function or a feature that someone or some object has that is called a function in function programming. And then an object-oriented programming is called a method. And then in function programming is also called variable, which is XYZ, those variable you define. But in object-oriented programming, a variable is called an attribute or a property. So each object could have been instantiated based on the class that you have it, and then encapsulated into an object. So when you instantiate it in some programming language, when you define an instance of an object or a class, instance of a class is an object. So when you create an instance of a goose or a duck or a turtle, each one of them you have to instantiate it. Now you define the name of the goose or the duck or the turtle or the fish or the bird. Once you just give it a name, that's one of attributes. The size, the color, the shape, the all of these ones are a part of the properties that that object can take. And then what are the methods or functionalities that that object can do? For example, if you think an object as a person could be an employee. An employee functionality could be a full-time employee, part-time employee. You could be a student, you could be a teacher, you could be a soccer player. You could have all many different objects of those types. And at this time, I'm looking at two fish there. Then you can see that the fish has a different lung, that the method or the functionality that a fish has is that inside water can swim and outside of water they die. But on the other hand, turtle, it could take multiple form or polymorphisms. So inside the water they can swim, outside of the water they can walk or sleep or whatever they want. They can do both there. God has given him all kind of features for each of the animals. Look at the bird, just walked in and then it flied. So flight away, meaning that that method was part of the bird's functionality that allow him to do so. So in this video, basically, I'm teaching you object-oriented visualization. We have learned function programming, and from function programming by declaring variables and functions or procedure. The problem with function programming is these variables could have different kind of a scope within a function. They might have same function 1 and function 2 might have variable x defined on both of them. They might have conflict if you just define them outside of the global area of the programming language rather than that inside the function. So if you do it within the same function, if you just use the same variable name, sometimes they may interfere with each other when having conflicting there. The scope of the function or a scope resolution has to be there. Sometimes we call it like, oh, if you have 1,000 functions in a large program, or maybe 100 functions, then it's very, very hard to pinpoint the issue or the concept of a needle in the haystack. Sometimes you could say function programming is like a spaghetti kind of food that it's almost mixed up together, and then you just have a hard time to pinpoint the issue. Similar to like finding a needle in the haystack, which X variable at what function was defined at what time. So the scope may have lost it, and then all of a sudden these have conflicts. But with object-oriented, you don't have such an issue at all, because all the objects, each one of them, when you instantiate it, you create a new instance of that object from that class, let's say duck, and then you could define the attribute of that duck, and then the method that duck number one does it versus duck number two, and so on. All of these ones are very, very easily configured because of these four paradigms: abstract data hiding, which is kind of like private classes. Some of it, like for example, for employee, and that we were talking about, that if a person's name, like myself, I could, let's say I have a name, and then I have social security, I have a DMV driver license. Some of them is private to my own class. So that is not going to be known to the public. So you can do data hiding for the reason of having a clean or clear interface for the user to work with you. And then the other subclasses that are defined, whether it's full-time employee, part-time teacher, soccer player, human being, all kind of different classes that you can work with. They may have some method associated variables, but the encapsulation part is going to make it easier to just say, well, this part is private, this part is public, this part is hybrid, and then protect it within the subclass or so. And then inheritance is very nice feature, because usually all of these 5 classes that you can see, they all inherit the common attributes and properties from, and attribute and properties are one thing, but at the same time, they inherit all the common attributes and methods from their parent class, in this case, animal. And then if you look at like pets classes, like cats and dogs, obviously, you're talking about a subclass of cats versus pets. They each one have different methods. One could bark, the method, the other one could say meow. And then a fish, for example, doesn't speak, and the duck has a different sound. So all of those ones, you could just see their different classes, objects, and methods associated with it. And then I'm going to just see where I am on almost at the end of this video, but let me just go to the next part, which is this video, also as a short version of it. I made 2 of them, so you can see one of them on the right side. I'm showing you the 4 paradigm of object-oriented, which I already explained. The first one was abstraction or data hiding. Because when you create a class name as a template by defining a class name car, employee, duck, cats, pets, anything, you're just abstracting the detail, data hiding. Once you just go to encapsulation is the form of objects. Once you instantiate each one of them as a duck, as a turtle, number 1, number 2, then you're just putting those attributes and those methods with each objects, and you're defining it as a encapsulation, and that is that object. So that object, now you can do certain things with it, and you cannot do certain things with it. Inheritance is the same thing. That is like I just told you the definition of, for example, later on I'm going to show you another video of cats that they all inherit, especially for inheritance. Not this, for example, if you look at the turtle objects, they all have same kind of shape and colors and four legs, and then the paws. They're all inherit from their parent class the same kind of shapes. And for example, the goose, you can see the goose and duck, they inherit the paws similarly to the web kind of feet shape. And then they both can inherit all three of them are allowed to swim, including the fish, the fourth one. The bird, on the other hand, that is coming at the end of this video that is there, they cannot swim, but they can fly. And then you can see duck can swim as well as fly. So some of those methods that they inherit from their parent classes, child-parent relationship, are also called inheritance. And then also polymorphisms, as I mentioned, like for example, the turtle could just have different forms, and then at different time, depending on what they want to do. And then same thing with duck, same thing with fish, same thing. Every object most likely can take many forms and to do something at different times. And then even human beings, sometimes we're happy, sometimes we're sad. That's a different kind of face for our characteristics of how human beings behave. So the fact that we cry, we laugh, we play soccer, we study, we do all kind of different forms, right? So we could be smiling, we could be laughing, we could be crying, we could be upset, we could be happy, all kind of forms depending on different behavior. You can see right now the bird comes in and all of a sudden he wants to fly, and then that's what happened. If he did not have the method fly as an interface, like a fish doesn't do it. Although some fishes you can see on the ocean, they fly a little bit, but they're caught by the bear. So here I'm just showing you a cat object. So the cat is a subclass of basically a subclass of pets. And then you can see there are two twin here. I'm showing you the cat's inheritance feature. You can see a cat could have many different attributes and methods that they all inherit from their parent class of pets or parent class of cat. So each instance of this twin cat is one of the example. For example, this twin, we call it, his name is Skinny, and then his brother comes in, his twin brother right there is coming next, and you can see that's Papu that is enjoying it, and they're very, very calm and nice little brothers. They're having fun, and then you can see the attributes or properties are very, very much similar. The colors, the shape, the size, the height, the width, and then even the way that they behave or they play. They all kind of like very a similar method, similar kind of running and speeding and reacting. All of those ones or attributes of inheritance, that the gene that they inherit from their parent class. So that is something that object-oriented provide us with these kind of different objects. And then the definition of a class, when you define a class, for example, a cat, you create attributes and methods to it. And then once you instantiate an object of cat, let's say Skinny, and then Skinny would be one object, the color, the shape, the height, the methods that are associated would be different than Papu. And then the methods are there. So this is object-oriented visualization. You're seeing the visual image of these objects. When I'm trying to teach you object-oriented, I want to make it as easy as possible by teaching you with visual images, so you can see what, when somebody talks about object, what does it mean by object. So you can see right now the twins are playing around with that toy or that little kind of object, that's also, you could call it object, because it has a size, a height, and everything in life you can call it an object. And then obviously an object has a name, a color, a size, a kind of status, and then whatever you can do with that object, those are methods. But notice that the one cat is playing and the other one is just watching it. So those are the certain behavior between the twins that they always do that one. They respect each other, they love each other, they play with each other, and they having fun together, and that's good cats. And notice that the type of, when they want to go on the ground, and they all kind of lying down on the ground to play with that object, because that object is very small to do it. So they don't stand on their leg to just play with it. Usually that's the case. So abstraction is another type that we talk about it. And every object you can have these abstraction, encapsulation, inheritance, and polymorphisms. And then I'm showing you the object-oriented visualization. You just saw a nice interface. A second one is that I'm just showing you here is that this object is of two cats, and then the last one I'm showing you is also, let me play this one. And this one was a video that I posted. I think the sound is a little bit too loud. I'm going to make the sound lower. But on this one also, I'm teaching you basically the object-oriented visualization of the twins, the inheritance features. You can see they both inherit a similar kind of like jumping together. As you can see, that is a method, jumping together at some point. One kind of triggers the other one to say, come play with me, watch. He looks on the side, and then all of a sudden, right there, he makes a jump, and they both engage together. That's kind of like, even though animals don't talk, but their look and the other ones, I have noticed that they are very, very kind of like alert, and they make that kind of judgment. So I'm going to play this video one more time. You can see that second, that when he looks and then they both play, that's something inheritance. They both are twins, so they can communicate that way. So that is a good thing that you saw that one. I hope you like this video. I hope you enjoy it and you learn something. Usually, this video, I made it for the concept of from functional programming to object-oriented programming to object-oriented visualization. In real life, everything is exists as 3D and visual kind of images, or a human being or animals or birds or any classes of cars and toys and everything. But everything could be a class, and then everything in an object is an instance of a class, and a class has attributes and methods, and then you can do a lot of easier way to code, and then code reusability as part of the object-oriented programming. So you can instantiate an object, and every method that you call it, you just pass it on, and opposed to variable declaration that we used to do on the old procedure programming kind of languages, that nowadays they don't use it as much. But all the programming languages such as Python, C++, and Swift, and let's say Go language, and all these other ones that you can name them, PowerShell, all of them, they allow you to do object-oriented programming. And I hope you start learning object-oriented programming as well as object-oriented visualization. Visualization is when you see it in the form of graphical. It's much easier to see what an object is, because a lot of people that they are programmers and other ones, when you talk about object, they cannot understand what's abstraction in an object, what is encapsulation means, what is an inheritance, what is polymorphisms. And the more you practice with them, you don't have to know it, the syntax of every programming languages, but most likely, if you know how to write an algorithm, then you can just put it into syntax on a given programming language and we do it. And if you do the same thing with object-oriented programming, if you can visualize something, then it's much easier to define the attributes and the method associated with that object and then get the work done. Okay, so have fun, take care, and God bless you all. I'm just going to go through my website here, which I showed you the website. The website is actually MyWebUniversity.com, and then I have a lot of videos on it that I have posted on YouTube, as well as I have also have the entire book called The Direct Path to Linux Ubuntu, which is about 14 chapters. And this one, you have a lot of technical documentation. I hope you guys are into learning. And then I have made all of these 14 chapters for you, especially 32,000 PDF files and these chapter 8 through chapter 14, that you can just see them, all of them. By each one of them, when you click on it, you just get it. For example, if you're learning Red Hat Enterprise Linux, there's about 12,000 PDF files here. All you do is just click on it. Someone says that, how do I just download these ones? If you just want to download them, yeah, you're welcome to download them, but you don't need to. Basically, just go to the website here, and then when you just click on a PDF file, you just get the documentation here. So whether you use your cell phone or a browser, on a desktop, laptop, anything, you can read the entire documentation online. It doesn't matter which documentation you click on, you get the PDF file here for you. So it's a fingertips kind of a button. And if you are saying that, well, I like the C++ header files or Linux Rocky Red Hat Enterprise, there's about 11,000 on Rocky Linux. So the one that you click again, and I just give full credit to MyWebUniversity, my website, Python programming, the Rocky Linux manual pages that I use to generate this documentation, and the free PDF modules, and that I wrote the program to generate the Python program with generating these 32,000 PDF files all together on my website. At the same time, if you're looking for something that you're interested to say, let me just learn all these commands, you can click on, like, for example, Bash PDF. You could just click on it, and then you could just click on this, and you see the Bash PDF. And if you say, what about, we were learning Java, can I just, I'm sorry, object-oriented, can I get like something like Java? Yeah, you could get some documentation there, but in order to get full documentation, you have to go to java.docs. Java.sun.com or Java Oracle.docs web page or somewhere. And then at the same time, if you're looking for something like, let's say Node.js, you can just get the documentation here and then read the Node. And then notice here with the Node.js, all the PDF file are here, as well as on Node, you can say, take me to nodejs.org. So one part of object-oriented programming that I wrote this Python program to generate it was code reusability. So all these kind of like references that are linked here, I just made it available for you. I didn't have to rewrite it. So and now you can go to the nodejs.org website. Or similarly, if you come back here and say, take me to the API, and notice that the code reusability, I just have this this Python PowerShell, Python PostScript PDF file that I generated, and you can see that it's the API here. It takes you to that website. And then you just go here and then search for anything that you want. Let's say the DNS, you could search all the method and functions of that one, or just go to domain. Whatever you want to search, the documentation is there for you. HTTP and then so on. and then the methods for OS modules, everything that is there, right? So you can see like OS here, the path module, and then for each of the module, there's all these methods. Notice that every module is like os.timdir. So this is just a function or a method. And in case of the Node.js is a JavaScript, OS is the module, timdir is the method. So so object-oriented programming allows you to have an object and then certain method associated with it, you can have it. And a method, an object that could have also variables. Like for example, here is the speed is a variable attributes, and that is defined. X is a attribute, or Y is a attribute, some values, right? So I hope you learned something out of my website here. There's a lot of videos here that I have posted. Some of the entire book is like, for example, Red Hat Linux Rocky. This one is a lot of people love it, and they have made nice comment. I really appreciate your comment. Those of you that watch it, it's about 4 hours and 12 minutes or something. And then Rocky Linux, the whole book is there, the whole class, full class, and then Red Hat Enterprise Linux 9, and then Linux advanced levels, and then introduction to Oracle Sun Solaris, Solaris 11, and this free PDF documentation. A lot of you guys have been watching it, and PowerShell, shell scripting and extern. So there's a lot of videos here. Lately, I also have been making videos on latest one on the PowerShell, and then Linux PowerShell, also called PWSH, PowerShell LTS for long-term support. There are videos on this one that is there. PowerShell is also object-oriented kind of programming, even though Python is much, much better, but PowerShell also does a lot of stuff similar to Python that you can do with PowerShell. A lot of things on the Windows platform, as well as now Linux Debian distribution, as well as Linux Fedora, like Red Hat or Rocky or CentOS. You can do that one. And then also I have MyWebUniversity in Farsi, that if you're learning Farsi, please join my channel so I can make more videos for you, and then show your interest. That way I know you're kind of interested to learn. لطفاً کوشش کنین که عزیزان ما کسایی که فارسی میفهمید به چینل ما سابسکرایب کنین که من بفهم که شما عزیزان میخواین که یاد بگیرید. If you want to learn, I will help you out. If otherwise, it's really tough for me to just create video and nobody shows interest there. God bless you all, and then I hope you're going to join for the journey that I have with you, and then we all could learn and help our community and society around us. And I wish you all the best. Take care. God bless you. Bye-bye.